Hello everyone, and welcome to tonight's presentation of OTF Connects, introducing measurement with the four-part math lesson framework with Kyle Pierce. We're really thrilled to have you all here again with us tonight. Many of you are repeat attendees with OTF Connects, and I imagine a few of you were in Kyle's first four-part math lesson framework session that was not too long ago, and he's got a couple more coming as well. Thank you all for giving up some of your time tonight, and on behalf of OTF Connects and all the staff at OTF and Sirius Gurhan, the administrator and facilitator, we're always happy to see teachers who are eager and excited about furthering their own learning and that of their students. So we're also thrilled to have Kyle with us tonight. And I'm just going to share our map of Ontario, where everyone is all spread out across the province. So thank you for letting us know where you are from. And Kyle, I'm going to hand things over to you now. So you go ahead and switch back to application sharing mode, and here we go. And look at that, that flashed up instantly for me. So hopefully everything's looking good, and we will hand this right over to Kyle. Thank you.
All right, everybody. Thanks so much, Louise, for the introduction, and welcome to exploring measurement with the four-part math lesson tonight. So I've recognized some of the names there. I see Aaron on the screen. I've seen a couple other names that I've recognized from the last session as well. So welcome back. Thanks for coming back to see where this is going to next. We've had a few little technical difficulties with the slides, so I'm actually, for the first portion, I'd like to, I think I will actually run my PowerPoint, or my presentation here, and I don't know if, Louise, if you could just confirm for me, is it still looking okay for everyone?
Yep, everything looks good. And you know what, Kyle? The switch to whiteboard and back again was so smooth that I think we could easily switch to a blank whiteboard screen when you want to do the sharing and then back to your PowerPoint.
Perfect. Okay, so we'll try a first for everything, right? So we'll give it a shot, and if there's any problems, don't hesitate to let us know in the chat box. And I know right now I can't see the chat box. So feel free, if you want to raise your hand, if there's something want to get my attention, I can quickly jump out of the play mode and answer some questions. So I want to make sure that we're addressing any of those questions, any concerns you might have, or if there's any tech issues as well. So thanks again for joining us tonight. And actually I'm going to just jump out for just 1 second here. There we go. Perfect. As we discussed in the last session, we looked at the way I remembered math class, and I know that there were some folks in the room who, or in the chat pod, who could kind of relate to this type of math class where we would take up homework, look at a new section, usually give students definitions, formulas, procedures, and then we'd head straight into some examples in order to help them or ensure that they would be fine with their homework. And I saw that there was something happening in my class, and what was happening was I saw two groups of students forming, and these two groups were ultimately a group that was good at math and another group that wasn't so good at math. And for me, what I had noticed was as I was teaching in that way, in that style of giving students all of the answers and giving them all of the formulas without really giving enough time to develop these formulas, ultimately I was really promoting that good at math group. But ultimately over time I realized that good at math group who knew the terminology, they knew the procedures, whereas those in the group, the not so good at math group, typically struggled with those two things. And after doing quite a bit of thinking, what I realized was that when I was assessing good at math, I was actually assessing the students who are good at memorization. And those students in the not so great at math group typically were unwilling or unable to play that game. So you had some students who really struggled with pulling some and recalling some things from memory, especially in the way we were teaching math and the way I was teaching math, which was, new section today, we'll do a quiz and, in a week, and then a test, and then we would leave it. So, I mean, we were introducing concepts and not necessarily building on those concepts. So we're going to explore that a little bit tonight in the lens of measurement. But the other thing that we did discuss in the last session was the not good at memorization, or the not so good at math group, typically they, as well as a good chunk of those who were good at memorization, typically struggled with unfamiliar problems. And what I was finding was, and this is really what made me realize that a lot of my good at math students, and I'm using little bunny ears here as I say it, a lot of those students were just memorizing, and because of that, they didn't really know how to handle questions that looked unfamiliar. And I'm not talking about questions that are just, brand new concepts. We're talking about the same concepts, but a different style of questioning. So maybe it was a different wording, maybe it was just a lot of times I was giving students questions that looked very similar to an example in the note. If I was to go to another textbook and grab a practice problem, I would stump a bunch of students, and that really concerned me. So ultimately, what I was finding is that after time, as I was giving students assessments, if those assessment questions didn't look like an example, so as I got near the end of the test and I was trying to challenge my students, get them to think outside the box, if it did not look like an example, if it didn't look like homework, or it didn't look like a sample problem from the textbook, students were literally thinking that I was unfair. And I'm sure you have some students that might have, called you other things as well, not just unfair. But ultimately, these students were saying that it was unfair because I hadn't taught them how to do that question explicitly. And for a while, I actually allowed that to kind of modify the way I assessed. I thought maybe they were onto something, maybe they were right. But I realize now that ultimately what I was doing was I was changing the rules of the game mid-test. So it'd be like playing hockey, and then with 5 minutes left in the third period, there was changes to the rules that you could do whatever you wanted. And ultimately I was telling them for 95% of the test that you could memorize and you're going to do great. And then that last 5%, it was, hey, now you guys have to truly problem solve. And that really concerned me, because without the problem solving, we're really not offering them too much. So with those students who were good at math, one of those pieces that I was considering was the fact that if those groups of students who are good at math, if I'm really assessing them based on memorization, which meant recalling facts, doing problems that looked very similar. So for example, question number 3 on the test looked like example 6 from Wednesday's note. And I would even tell students this when we would talk after a test, and I'd say, if you really did your studying the night before, aka cramming, you would have noticed that this was right out of your example, or this was straight out of your homework. And that was something I used to actually say to my students. And I realized that by saying that, ultimately I was really promoting that memorization. So that was a concern to me. So when they were saying that I was being unfair, they might have actually had something, they might have had a point. Now for me in high school, not so impressed with this picture, but ultimately me in grade 9, luckily for me, I fell into that good at math group. However, you'll notice where I am, and it looks like we've got a question from Louise. Go ahead there, Louise.
Kyle, know what? I'm so sorry, but I've just realized if everyone's on the same page as me, we are still looking at your title slide.
Okay, that's a problem.
Yes. All right. So are you in play mode, or are you in...
I was in play mode, and I just popped out of play mode just about 20 seconds ago. So I've tried it both ways.
Can you go back to your view where you see your thumbnails on the side? Because that's what we're seeing.
Yeah, is that where you are right now?
Yes.
Yeah,
people are putting in the chat there that thought we were just chatting. Yeah, and I was following along great. So we're very sorry that we missed the visuals, but the conversation was good.
Now I don't see any. Okay.
When you click on your thumbnails, have you clicked on them?
Yes, yeah, definitely. Like right now I'm on slide 20. So,
Oh, goodness gracious.
yeah.
Okay, you know what? Oh, I wonder if we're frozen. Okay, you know what?
It says on
I'm
my
going to pop
screen,
us
it says
back to
hosting
white.
is paused. So I don't know.
Oh, that's why.
Hang on, let me try this. Does this
Okay,
work
you know
now?
what?
How about now?
Yes, that's working.
So there was like some
Yes.
sort of, it was a spinning wheel there. I just tried to reload it again. Is it, looks like
Yes, it's reloading, and now we see your good at math, not good at math circles with a picture of your high school self.
Oh, there you go. Well, there was a lot of other stuff in there too, but that's okay. You can see the thumbnails, I suppose.
We'll post your slides on the resource page, and we can go back if
That's all right.
the conversation was enough on its own.
Well,
too.
at least
There,
it's not
Hester says
Monday
there
after
we
the
were
lunch
active
break,
listening.
right? I'll be ready for the break when it comes. And we had
I think
active
we all
listeners.
will
That's
be.
pretty good. Yeah, no problem.
Okay,
Awesome.
perfect.
Well, I'll keep going here, and actually, when I changed this slide, did that change for you guys?
Yes, it did. Okay, so maybe you can just add in there changing slide now, and we'll be observant for that change.
Okay, perfect.
Thank you.
No problem. So yeah, as I was mentioning, as we were going back, and I suppose just to give you kind of a visual of what I was trying to describe, can you guys see that two groups of students? Just a quick yay if you can see that. Yes, perfect. Aaron can see it. Awesome. So we have two groups of students, and ultimately, the piece I was really trying to promote here was the idea that not all of my students that were in that Good at Math group fell into this category. I had, and I'm sure we can all name, a few students that we've taught over this past year, maybe past couple of years, where these students were students who actually, were problem solving. I could give them anything. I could give them an unfamiliar problem, and they would do just fine. But however, a good chunk of these students who were doing well in math never really felt like they knew exactly what they were doing. A lot of it was pure memorization, and as I was mentioning, with myself in high school, I did fall into that Good at Math group. But you'll notice the section that I am in here, and I'm in that memorization group. For me, the wheels fell off in university. When I realized, and my professor essentially told me that I did not know anything about mathematics. I knew a bunch of things that I could copy and imitate. However, I didn't really know the math. And for my friends in school, like many of them fell off the wagon a lot sooner. Some students it's in grade 6, some students it's in grade 8, and I think that this piece about the procedure and the algorithm that we're handing over to students, it's really dangerous to do, because it's almost like turning 16 and then saying, here, go fly that plane over there, right? Like there's a lot going on there. It's a really powerful tool when we hand over mathematics as an algorithm or as a procedure, because ultimately these abstract concepts are very, very, very powerful, and they have a lot of meaning. They have a lot of meaning underneath them. However, if we don't allow our students to see that, then they'll typically struggle. And ultimately, what I feel is really lacking here, and what lacked for me, was the fact that I was learning new knowledge, and I would learn new knowledge and I would memorize new knowledge. However, what I failed to do was to find a way to connect it to prior knowledge. And there's an abundance of research that tells us that anything we learn has to be built on something we already know. So if we're just doing a bunch of steps that are really meaningless, and we can't see where they came from, we're eventually going to forget those things. And that's a real problem. And for the students who do remember, students like me who managed to make it through all the way into university, eventually, we're going to be put in a situation where we really do need to problem solve. And the example I like to use is going into a job. If I'm hired for my math skills, and I go into a job, and my boss says, okay, I'd like you to solve this problem, and then what am I searching for? I'm looking for the example. right? If I don't know how to actually solve the problem, if I don't have an understanding of what's happening with the mathematics, I'm not going to be able to solve the new problem. We're not going to, and especially our students are not going to be hired to solve problems that have already been solved. They're going to be hired for problems that need to be solved, and they're going to need to be creative about it. So that's where we come in, and you know, I'm hoping that we can help with that. However, we did look at a textbook as well last time, and we looked at examples, how they weren't engaging. But the piece I want to talk about tonight is that textbooks oftentimes will actually silo the work down into different sections, which are ultimately supposed to connect to each other, but the textbook typically keeps them kind of locked off in an independent sort of nugget, right? So when you're doing section 5.1, oftentimes section 5.1 might build into 5.2. However, 5.2 problems, you're not going to see anything like you saw in 5.1 anymore. So, you know, they really try to filter the problems down so that it's very, very explicitly related to that one topic. Whereas we really need to be exploring these topics on a regular basis. We can't teach Pythagorean theorem in September and then not use it again for the rest of the year and expect our students to understand what Pythagorean theorem is come the next school year. And the same goes for proportions and for, you know, any other type of mathematics. So as we move forward, I did share a vision with you. So for those who have seen this, I apologize for repeating, but ultimately I feel that if we take what we're doing in our classroom and we really try to make our math tasks contextual, visual and concrete, as well as showing and modeling the interconnectedness of mathematics. And that one's a really difficult one to do because, you know, we're so concerned about time, but we really need students to understand and see where everything all connects. I feel that we're going to see student confidence increase. We're going to get an improvement to student perception of mathematics, and we're going to see overall student success improve, which may be in the form of credit accumulation in high school, graduation rates, as well as EQAO scores, which I know is only a snapshot. But ultimately, if we're doing these things, we are going to see improvements on these one snapshot type assessments that wrap up an entire year of content. If there's a true understanding there, the idea of reviewing a week before to cram is really not going to be necessary because there's going to be that deep understanding. So we also looked at the 4-part math lesson. So many people had seen what a 3-part math lesson had looked like. Ultimately, all I've done is I've just taken this, I'm taking this 3-part math lesson and I'm breaking down the middle action piece into 2 very specific parts. The 3-part math lesson has the minds-on, action, and the consolidation phase, whereas I think it's so important that we break down that action into a very specific set of procedures or a specific process when we're introducing a new concept. And that's that inquiry piece where students can see where things are coming from, where they're building from, instead of just simply being given the power of that algorithm. Now, when we take that vision and we look at the 4-part math lesson, we can take these 2 things and I think we can actually put them together in order to make it more of a, connected cycle for learning new math concepts. So, you know, doing that now, what I feel is that contextual, visual, and concrete phase, that's an excellent opportunity during the minds-on to sort of set the stage. And you guys saw in the last session, or some of you saw in the last session, how we could take one concept and build it into a new learning goal later. So the minds-on doesn't have to be a specific separate task. It doesn't have to relate directly to the previous day. It could be setting the stage for only this current day. So it's very flexible. However, if we can make it contextual, visual, and concrete, then we're in really good shape. The next piece would be that connection phase. The connection phase, I feel, is where we help students see how interconnected mathematics is. And this is the piece where we help students take what they know and connect it to a new learning goal. that inquiry piece is typically setting the stage for those connections. So taking your inquiry, taking your prior knowledge and your intuition and using it to help scaffold us to those connections. And then finally, consolidation, where we're applying the new skill through practice. And I want to be clear there as well that the consolidation phase does not have to be, it does not have to be as visual as the minds-on or the inquiry piece. You might be working towards an algorithm, and that means fluency with procedures. So that's where we want to get students to, so that they have a comfort with the visual, the contextual understanding, but then also with the abstract understanding as well. So with that being said, we typically have a 4-part lesson in that vision cemented into one. And today we're going to look at what that might look like if we were teaching a lesson on measurement. So before we do begin, when we look at measurement, I often think of area, perimeter, and volume as those 3 kind of key areas of measurement. I know there are many different concepts, but today we're going to be focusing on these 3, and more specifically perimeter and area, in terms of setting the stage for where we're going to go in this particular lesson this evening. Now, when we picked perimeter, area, and volume, I really wanted to go back and I wanted to dig deep, because as I'm a grade 9 applied teacher, and I do instructional coaching in the afternoon with 7 to 10 math teachers. So for me, I look at my grade 9 applied students who typically have struggled in math, and I often wonder, when were they first exposed to perimeter, to area, to volume? And why is it that there's still such an unclear understanding of what it really means? And when I went back and did some digging, we can go back to grade 1 and see in an overall expectation the concept of length, mass, and capacity. Sorry, length, area, and capacity coming out. Now, this doesn't mean that they're actually using any type of formula for it, but I mean, they're being introduced to these concepts very, very early on. And when we move forward into grade 4, we can see that we're actually talking about perimeter and area, as well as volume. So now not just capacity, but volume, the word volume is coming out as well. And then finally in grade 5, we're actually using a formula to find the volume of a rectangular prism. Now, most of my grade 9 applied students, when it comes to finding the area of a rectangle or volume of a rectangular prism, typically do so without much issue. And it could be because it's much easier to visualize, it's much easier to understand that concept. However, they have a hard time applying it to other areas, such as finding the volume of a triangular base prism, or finding the volume of a cylinder. So we're going to look at some of these things today to see if we can't set the stage for helping these students when they're being introduced to something like area, perimeter, and volume. So the first piece we'll take a look at today, we're going to kind of engage as though this might be a minds-on in this particular case. Near the end, I'll go through kind of one cycle, and we're going to focus on the perimeter, area, and volume, very, very lightly on the volume of a rectangular, of a rectangle and a rectangular-based prism. And then afterwards, we're going to look at some other options, what this might look like in other topics, okay, or other types of 3D shapes and 2D shapes. So with a minds-on, again, trying to make this visual, contextual, and concrete, we could start with something as simple as what you see here, which is just a simple plastic container that I've used from around my house. A couple of weeks ago, my wife and my daughter were getting ready for dinner, and they were cutting mushrooms. So the first piece we can do here, before students even really have an understanding of what perimeter or area really is, we can get them thinking just about what area really is, like how many would fit along the bottom of this particular container. And typically I would have my students chat this out, and you'll usually get some really interesting questions come back. And part of this, I believe, is because there are no numbers here. And they're using more intuition than mathematical knowledge. So if you throw out an answer, you're not going to feel bad if you're wrong because there really wasn't enough information to know for sure. And some of the questions I might get with this particular question is, are we talking about like how many will fit in the entire container? Can the mushrooms overlap? Like all of these different pieces. And ultimately what I want them to do right now is just take a look and take these mushrooms, and if I could fit a mushroom in here, what would it look like if it was full? Get kids thinking, and we'll get a different array of information. So I'm going to give you guys a second, and just in the chat box, if you guys want to throw out your guess, how many mushrooms, and I will clarify, I'm sure there's some of you that have an idea here, but again, these mushrooms, we're not trying to fill the entire container, the volume of the container. We're actually just trying to cover the bottom, and we're not going to have any overlap at all. All right, looks like mostly the number 6 is coming out, and typically that's what I find in class as well. And that's not a bad thing, obviously, right? We want students to feel comfortable putting out information, putting out answers. You might get a student who comes back with a different number, right? Like we have a few here coming back with 8 and 12, and that's okay. We have them try to argue it out, right? Try to discuss why they believe that to be the case. And then when I show them, when I take this information and I actually show them what it looks like, you know, we have a really good conversation here about, well, you know, why that wouldn't be the case in the real world, right? Mathematically, the way we've set this up, or visually, you know, that seems like a perfect case scenario. However, this is unlikely, and I told them, yeah, absolutely, this is definitely not the way we bought these mushrooms. However, just getting them thinking about covering the area, right? And in this particular case, we get students to really think about what's going on here. So in this case, we actually have 6, and we want them to start thinking, and I love in the chat box here, we have Mary Jo, she says, trying to stress that it's measured in squares, not in length units, which is awesome. Now in this case, when we have this mushroom, a lot of students will say the same thing is, you know, like what would the units be here? And ultimately this would be 6 mushrooms squared. All right, and you'll notice there I don't have the squared in on my slide, but I should. So the idea that it is actually taking up a square of space because of that no overlap rule that we're working with here. And when we look at the perimeter, how about the perimeter, folks? What do you guys think will the perimeter be? If this is our case, if this is our particular package or our container, what would the perimeter of this container be? Sometimes we have some more you know, varying answers coming in from our students. So take a second in the chat pod. What do you think? Couple 10s. Someone Ian's saying 8. 10 as well. Now, oftentimes I'll get students that will actually say, they could say sometimes 14, and I'd be curious to know if anyone can guess why a lot of students might say 14 in this case. There you go. So Christian, right on the money. So a lot of students will start arguing about the idea of the corners. And so sometimes what I'll do when we're doing perimeter is I'll actually put it on top of the package. So when they start to see this, they can see that we actually do have 10 that fit around. So you'll notice we haven't even brought in any sort of algebra. This is kind of a minds-on, getting kids thinking, trying to figure out what they know about area and perimeter. Do they understand what they mean? And you can, you know, get a good sense for where your students are when we engage in something like this. Now, I might have a couple more examples of this with my students to run through, but rather than do that again with you guys here, we'll take our next step into the inquiry piece. So getting students to use that prior knowledge, that intuition, and just like in this room here, it's clear that you guys have you guys have a understanding of what those two things are. So there's a lot of work that can be done before we even introduce a formula. And I keep getting distracted because I want to get in on the conversation in the chat box. I think it's great that that you guys are chatting in the box there, and there's lots of great discussion. So that's always a good thing. So we're going to take a look into inquiry. And yes, by the way, this is Keynote, Apple Keynote software, and it is really smooth when you use the Magic Move slide transition when you're doing a live presentation. So in the inquiry piece, I want to get you guys thinking here. Again, something from around the house, just a container of eggs that was sitting around the house. And when we open this thing up, the next question I have for you is, what is the area of this particular egg carton? So go ahead in the chat window. What do you guys think? What is the area of this egg carton? Nicely done. So pretty basic stuff, right? So we're definitely looking at an area of 12 here. Some students say, you know, this one should be the first question instead of the mushroom because they see the indents, right? You can see where the eggs are actually going to go. So in this case, we do have those 12 eggs. Want to be particular that it is 12 eggs squared. And I like to really model this for students as well. And I think it was Mary Jo who had mentioned that, trying to be really, really clear on the idea of it taking up an entire square. So really awesome stuff. And in the chat pot, I did read your comment about your conversions with area, and I think that's an excellent idea as well with the chart paper. So awesome stuff going on in the chat. So now, how about the perimeter? What is the perimeter going to be? And then we'll start digging into to some slightly deeper concepts here and see where we can end up for today's webinar. Awesome stuff. So people are coming back with 16. So again, really able to visualize or help students visualize that. And we call this measurement with non-standard measuring units, right? Like we're not using just centimeters or kilometers or inches or whatever it is that we're actually going to be typically doing when we introduce measurement. Oftentimes it can be really useful to use actual things, actual physical objects, and you can do these types of activities in your classrooms using erasers around the desk or whatever it might be, because ultimately students are using a ruler, and that's kind of abstract. The idea of a centimeter is abstract, comparing it to an actual object where they can really get a sense for how many of those objects it would take. So excellent stuff on the 16 eggs. And now here's my question for you is, what is the volume of this egg carton? So going back, and I'll let you guys put this into the chat pod, what is the volume of this egg carton? Because when we talk about the interconnectedness of mathematics, oftentimes we'll teach area in almost like a batch. We'll teach perimeter in one big chunk, and then we'll teach volume later. Whereas oftentimes what I'm finding now is that these concepts build on each other so nicely that you're almost better off looking at all three within a relatively close amount of time. And then when you go into another, maybe wait a week or two in order to do the measurement of a different shape, a different base. So maybe with a triangular prism, you can then cover your perimeter and area at that time as well. And that'll give you an opportunity to bring back the idea of a rectangle and a rectangular prism. So we have 12 eggs cubed. I don't know if Jackie's was for the perimeter. I'm assuming Jackie's is for the perimeter. Sam says 12 eggs cubed. Ian says 12. Nicely done. So in this case, we do have 12 eggs cubed. So I find it's really interesting when students see that this volume is the exact same as the area. And that really gives kids kind of like, you can almost see the, the wheels turning in their brain when they're going, huh, that's interesting that the volume and the area can be the same thing. Now the units are different, right? We're looking at cubes now instead of just squares. So that to me is really interesting. So then what I want to do is now talk to students about, well, what about these two guys? What's the total volume of these two containers? So go ahead in the chat pod, what is the volume of those two containers? And then we'll start doing some deeper digging. Awesome stuff. So it seems fairly obvious, right? And as teachers, I hope you forgive me for this. I'm not trying to insult your intelligence. I know that every single one of you is looking, going, wow, this is pretty easy. However, that's exactly what we want from our students. Nothing makes me more excited when a student, or when all of my students are saying, this is too easy, because sometimes students can struggle if I jump straight to the abstraction. So when we look at this guy, 24 eggs cubed, now at this point, now that students have actually seen some of this building and they've done some of this stuff, using inquiry, chatting with their neighbors, almost essentially using only their intuition in order to answer some of these problems, we can then move on to make some connections. And when we talk about making those connections and using these visuals, we can take what we already know, such as finding the perimeter of this mushroom container, and really help students understand, or, sorry guys, my slide deck, there we go, sorry about that. Sorry, we could take what we already know, which is our area of 6 mushrooms, and really outline the idea of an array model so that students can see that formula kind of developing, that length times width formula. And when we look at the perimeter and actually start building what this really means, when we look at 2 plus 3 plus 2 plus 3, and they start to see, again, my slide deck is kind of buried, there we go, and they can actually see that there are 2 lengths or 2 widths, it doesn't matter what you call them, and 2 of the other, so I'll call these guys widths, they can start to develop this formula and bring it together by rearranging, bringing those lengths to the front and the widths to the right. They can see that, you know what, we actually have 2 lengths and 2 widths, right? Like, this isn't a bad thing for students to see, and the next step I'm going to show you is grade 10 common factoring. We don't even do this in grade 9, but it's something that would be beneficial for some of our students to see that when I have 2 lengths and 2 widths, it's the same thing as 2 of our length and our width. And by doing that, they now have sort of taken that idea, that use of distribution. We've done the opposite of distribution by pulling it out. Now, it might not be super obvious for some students. However, this is something that we can help them make these connections. All right, so trying to see that there are different ways to do it. And I see a question coming in from Hester. So go ahead there, Hester. If you want to turn on, if you have a mic, you can go ahead and turn it on. And otherwise, you can type it into the chat box. Go ahead. No problem there, Hester. Is the question already up, maybe, or possibly? I just missed it. And while I wait for Hester to come in with his question, it says, how much time would you spend on the inquiry piece in a grade 9 class? And you know what, Miss looks like, or it could be Mr. Pope, I'm not really sure, but that is something that I really, really hesitate to give some sort of answer to, because the inquiry piece could be very, very small in some lessons, and it could be very, very large in another. And I find that there are times when a full lesson might be more of an inquiry lesson, and then the next day might be some of that consolidation and connections. So, when we talk about the, 3-part or the 4-part lesson, I think we have to be really cognizant of the fact that there is no one way to teach. There's people that are excellent math teachers that are not using, let's say, a 3 or 4-part math lesson, but they're doing many of these same things in some way, shape, or form. So there is no silver bullet there. So I would say, as long as you think it takes for students to gain that understanding, I think that it's an investment of time that will pay off in the long run. Now, unfortunately, you might not see that immediately. And, if, let's say, we're only using inquiry every so often, then we might not really ever experience that, that benefit. But if we do it, and, as long as we keep balance, and as long as we don't forget that part of the puzzle is procedure, is algorithm, but I think we need to have students build, construct their knowledge to that algorithm, because the algorithm is useful. It is very useful, but it's so much more useful if students understand why it works and where it came from. Now, it's not always possible. I want students to understand what it looks like to do Pythagorean theorem, but I don't want to spend a week trying to have them figure it out on their own. I want to put them in a position where they're going to kind of bump into that learning goal. I use that expression quite a bit. So finding ways where they're going to see it without it just being a step-by-step here, do this, do this, do this, do this, and then all of a sudden the answer's, before them. So it's finding that balance, that middle ground between, giving it to them and between them having to literally figure it out, and win the lottery in order for it to actually make sense to them. So I hope that answers that question. And then I'll go down to Hester here. So Hester says, I have kids who struggle with this algebraic format. They don't get the brackets, the letters, so how can you help them? And I would suggest that, Hester, you're definitely not alone there. When it comes to the algebraic, that's where I think the visual is so important. Like for me, and if I back up the slide deck just for a second here, when we look at, where I think most students would agree that we know where the length plus width comes from. And if we use some visuals, for example, to put together that we do have 2 lengths and 2 widths, I think students can make or they can become clear on that. So for example, even here, if I was to actually, talk about just the 2 lengths, for example, which would be these guys, and then the 2 widths, which would be the opposite, I could just take these guys away. I think students can build that understanding, but they really need to see where it comes from. So those 2 lengths, being able to really have them see it and visualize it, and the 2 widths, I think that's going to help them. And then finally, when we put it into brackets, ultimately getting students to see that when we put the length and the width in brackets, we're talking about 1 length and 1 width, but there's actually 2 of the length and widths. So, again, it's not going to work immediately with our students, but I think the more we're using our visualizations, the better off they're going to be. So, again, won't be overnight, but I feel that in my classroom, I've built a lot of, pretty confident math students because they can see what it actually looks like, and really trying to get students away from trying to just think of what that formula is. And I'm sure we all know that student in our class, the one that literally will take the formula for anything and try to make it work for anything. I have a student who uses, for any time he sees the word perimeter, he uses 2 times L plus W in brackets for every single shape. And it's clear that he doesn't understand what that means. So that means I need to work harder on my end to find more visuals, to find more ways to expose him to seeing those connections. And it's not going to just take that one lesson, unfortunately. I think it's going to take a lot more work than that. Just like it took us a lot of work to learn how to drive a car, learning how to do mathematics, especially when there are so many pieces, is really, really tough. Yeah, and Hester, I definitely can agree with you on that as well. You're going to have students especially, Hester, what grade are you teaching, if you don't mind me asking? 7, 8, yeah, absolutely. And I'm teaching grade 9, so we're essentially teaching the same students. You have students who, for 7 or 8 years, have been given formulas. For much of like the formula is easier, right? Like I think most of us realize that if you can memorize, memorizing the formula is much easier than understanding it. Right? Following my GPS is much easier than looking at the map on MapQuest or on Google Maps to understand the neighborhood. That takes so much more learning. But which one is worth it in the long run? If I'm only going to the place one time, then the GPS does it. But if I have to go back to this place in the future, then it's really a disadvantage for them. So. But anyway, I really appreciate the question. So I just want to, take a few minutes and head through looking at some of the area, for example, of the egg carton, really making it explicit for students to see, again, an area model is important. And this can really be helpful for students with multiplication in general. Right? Students struggle with multiplication, and unfortunately, a lot of students have different supports at home. Like a lot of students are going home to learn their multiplication tables. It's not necessarily the teacher that's teaching them. It might be parents at home that are supporting them in that. So when we look at helping students with multiplying, we have measurement is a great way to leverage that. We all want our students to have a better understanding of numbers, a better number sense. And when we go through the measurement units, typically we're handing formulas and students are subbing them in. They can get to an answer. So as long as they pick the right formula, we're good to go. And students typically don't struggle with them. But if we slow down a little bit and we actually try to leverage the idea of an area model, students can then start to build bigger concepts. And we'll look at this a little bit further in our next session on number sense and algebra, when I'm going to take some of these concepts and really show how when we have an unknown, things get really complicated for students. And that's where the wheels fall off for many of them, but it doesn't have to if we build their knowledge on these visuals. So again, I'm a little biased. I really believe in them, but I do see it working. So here we are with our egg carton. So just some ways for students to get that better understanding. Again, we can see those squared, those eggs squared. Our perimeter, again, same idea with our perimeter, really helping them see the formula building. So seeing that our 2 sides of 6 and our 2 sides of 2 is really the same thing as 2 6s and 2 2s, or 2 of the 6 plus 2 in brackets. So really trying to build that concept. Like we have an opportunity here for students to see how distribution really works in an application sense. So when we're teaching students distribution, rather than students saying like, why do we need to know this? Like we have a reason for it right here, a nice easy way to really make that connection. And then finally, for our volume, I know the visual gets a little tougher with volume. When we look at those 24 eggs cubed, getting students to see the area of the base and then times 2, because literally we're taking the area of the base just like we did originally, and then now we're going up by 2 eggs. So that volume of the length times the width times the height can really go far here, and students understanding that volume typically, it starts right from the ground level with area. And we see here we have 24 eggs cubed for that particular case. So with that being said, I want to take a moment here, and we talked about making some connections to these formulas, and I know we're dealing with a rather basic concept here, but I do want to give you an opportunity to see what that might look like in the consolidation phase. So as we go forward, I want to take a second, and I want you guys to take a look at this particular question. I'd like you to try to figure out, without me giving you any information yet, what do you believe the area of the base of this particular box would be? And then we're going to scaffold up into something a little bit more difficult, a little bit tougher, And then we'll explore some, we're not going to look at every simple shape. We'll go right to complex shapes, and we'll look at some ways that we can engage students in order to do some problem solving once they have this visual understanding. So go ahead and put in your answer. I love folks that are trying to use units right off the bat. Love it. Especially since I haven't given you anything yet. That is awesome when people are willing, especially my students, are willing to take a chance. I like that 12 circles square. That could really throw somebody off, eh? Us mathletes. Awesome stuff. So you guys can see that seems fairly obvious. Again, something from around the house. This is a box from my basement. Those are my hot peppers that I actually used on my dinner tonight. And when we look at this, we're looking at literally how many of these jars can fit in here. And Paul makes a great point about being tough on a one-piece student. I'm all about trying to make sure that students can use their intuition, but I also still want to challenge them in some way. So in this case, typically students will get students will, they get that concept that it does take up a square of space, even though it is a circle. So, I'm surprised daily when some of my applied students, who typically are students who struggle and have, IEPs and LD of some type, and they come out with some pretty phenomenal responses. So now, in this case, again, taking this one box, we can have them exploring and really trying to show what that area model looks like. So I have my students draw things out, and this is even in grade 9 applied. So whenever you're doing your area, I really try to get students to use these non-standard measurements or non-standard units in order to get that concept of like what area really looks like, because I think it's easy for us to forget. So in this case, you guys are right. We are looking at 12 jars or 12 cans of peppers squared. And now what we want students to do is to start bringing this concept and actually plugging this into their formula so that they can start to, I guess, avoid having to draw. And again, making sure that they see that we are taking up a square of space. And then finally, for perimeter, same idea here, same idea, and in making sure that students can see where that formula comes from, where the width comes from, and that there are actually 7 cans and there are 2 cases of those 7 cans, or two sections of those 7 cans or jars. All right. Now with that said, this is ultimately, after students do some practice with this formula, and they actually start using the area model when they're developing these formulas, what I try to do is actually give students something. For example, this is a visual that you can actually access on my YouTube channel, so I'll share that out in just a second. But ultimately, this particular animation really helps sum it up in about 20 seconds for students if they do ever get stuck, but just seeing that concept of where the length and the width comes from. And when we multiply them together, we end up simply dividing our shape in 2 and dividing our shape in 3 in order to get that area. So rather than even using any type of measurement or any type of unit, here we're literally just taking it and we're dividing it up. So we talk about our students struggling with fractions. Well, this is leveraging the idea behind dividing shapes up into fractions. So we can do this with area, and we can apply those skills from fractions and from their rational expressions. So again, really quick and easy for students to see, and then we can actually get them into another example. If I have a width of 4 and a length of 6, we can quickly see that this has an area of 24 units squared. And then we can literally scaffold straight into the volume of a rectangular prism by students seeing that, all we're doing is we're taking that area of the base, and the volume of a rectangular prism that has a height of 0 has a volume of 0. However, the area does have a value in this particular case. So when we look at the height of 0, all we're talking about is literally not having any sides on this rectangular prism. So if we were to pour water into it, it would just roll right off the sides, or stream right off the sides. But as soon as we pump this thing up to a height of 1, we can see here that all we're doing again is taking that area of the base and multiplying by 1. All right, and then finally, area of the base times a height of 2, and then finally, if we don't know what that height is, we're going to use a variable for it, and we end up with a formula of length times width times height. So even though that formula is one of the easiest formulas our students will ever use, it's still really important for them to understand where it came from, because if they know where this formula comes from, they can go on to other formulas like the volume of a cylinder and do the same thing. So I want to take a second here, and I'm going to send you guys on a web quest to my a little animation on the volume of a cylinder. So I'm going to send you on that quest right now. If we can grab that link. Where are you? There you are. In this video, we're going to learn how.
I'm just going to jump in for a second.
In just a second.
Know what, Kyle? I'm going to post the link in the chat. That will work better. So volume of cylinder, because they won't get the sound through your application.
Yep, I've got it up there for you right
there you go, folks. Perfect. Okay, so in the chat, guys, click one of those links and watch the video and come back when you're done.
Okay. Let us know when you're back there, folks. Thanks. All right, looks like most people are back. So once you're back, give us a green check mark, and then we'll carry on. Okay, great. So you'll notice there, showing you that video, I wanted to give you guys something that was a little bit more like the actual animation appears. The rectangular prism slides that I just went through would have that sort of animated look to them using the Magic Move slide transition. And ultimately, this Visualizing Math playlist, which I'm just going to put in the chat pod as well. So if you check out that particular link, you don't have to go there now, but just you might want to bookmark it for later. There's a bunch of other animations as well. I haven't made it through all of them, but they are quite useful in trying to visualize. So it looks like Louise has a question. So go ahead there, Louise.
Yep, I just wanted to mention that you may need there. Perfect. I was just going to say readjust your screen and we'll have the full thing back. Looks good. Thanks.
Perfect. Okay, so, all right, go ahead there, Mr. or Mrs. Pope. Hi, Sherry. To be honest, Sherry, usually I will use them as I will use them more or less to do some of that consolidation, and I do leave them obviously online for students to use. However, we will do that as a group. It's not something they do independently. They don't go home and watch it. You know, it's not like, okay, everybody go on your iPads individually and do it. This is something we typically will do together. And I always encourage people, when I'm doing it in class, I don't play videos that have sound. So what I'll do is I'll actually mute it, or I'll just run the slide deck, you know, the actual slide deck myself, so that we can have the conversation, so we can stop and go, or, you know, move as quickly or slowly as we'd like. You know, I find regardless of the video, you know, anything, you know, even under a minute, sometimes students are, you know, not so interested in looking, right? But if we can engage in conversation and keep them, you know, their minds activated while we're going through, you know, you can see some of those light bulbs going off. So yeah, and I think it's very similar for, you know, when I go to a PD session, for example, I'm constantly thinking of, you know, my students, because oftentimes I find a lot of those same you know, pitfalls happening, where I start to daydream, or, you know, I look on Twitter, and you know, the toughest part is trying to stay engaged in something that you're unsure whether it's going to really be important for you. And I don't mean important just for the test, but, you know, is this actually going to be something I care about? Right, and even when I go to a PD session, oftentimes, you know, unless you know that, you know, the speaker or the session, or you're really engaged in the topic, oftentimes you can find yourself not really tuning in as you know, as well as you might like, or as well as you might hope you would. So you know, you're kind of taking a gamble when you go to a workshop, and students do have this gamble every single day. They go to 4 periods, or if it's in elementary school, they're going, you know, for 7 subjects a day. And you know, they don't know whether that topic is really going to resonate with them or not. So I would suggest going through it with them, so it's, you know, happening as the class happens. I think people dislike the idea of something that's recorded or taped or planned, you know, to the T, or scripted, so to speak. So yeah, exactly, and I would agree there with Sherry on that. Yeah, it can be a tough sell. So trying to be careful is really important. So I want to take a little bit of time, have a little bit of fun with you here near the end of our session. It is 8:40. I know we did have, you know, obviously we're not in the optimal situation with the way we're sharing our slide deck here. But what I'd like to do is I'd like to take a second and grab, and I had them in a I did have them in a little link here, but what I'm going to do is actually have you guys check out a particular video, and we're going to have some, you know, we'll have you guys share out some of the questions that you might have. So I'm just going to grab it right now. And here is, oops, my window had shut down when I did it. Here we go. I'm going to share this link out with you as well in the chat pod. And I'm having you guys watch it. It's not a very long clip at all. As I recommend, keeping those clips really short is really important. But check out this clip, and then when you come back, I want you to type into the chat pod a couple questions that you may have about this particular question. It could be math related, maybe not math related. So check out that video, and then we'll come back. All right, a couple great questions coming back here. Christian, like your second question there, how much gas did it use? I actually did try. I tried my best to measure using a little dipstick, and just never got around to actually doing anything with those photos I had. But I should probably dig them up, because looking at how much gas was used could be interesting. Try to calculate maybe the miles per gallon of the lawnmower. Perimeter of the lawn's great. We've got quite a few questions there. So as you can imagine, lots of students will have lots of questions as well. Some students ask, were your neighbors looking at you oddly when you were carrying a camera around the lawn? And the answer is yes, they were. All kinds. What's the width of the blade? Lots and lots of questions that could come up here. And ultimately, for this particular task, what I'm going to have you guys do is, and you know what, we may not have a whole lot of time to do it, but we'll give it a shot. With this task, what I've done, and I do have a link for you, you can check it out afterwards. We'll have you refrain from going there now, because you'll see some of the solutions and so forth. But typically, I do have this information up online for you, so you can check it out. But the question we're going to look at is, how long would it take? And ultimately, this is what I'm giving my students. There's the picture of the house, and I've done my best to kind of model, give you an idea of what the shape of the lawn actually looks like when you consider the front porch and the little pathway there. There's also some modifications on this particular question that you can do. There's a number of ways that students can find the area of this lawn. And the other piece that you would need is about how long it would take in order to do one particular strip. And ultimately, what I've given my students is the fact that it takes about, and of course I've lost my little screen there. When we look at our part 2, we're looking at about 19 seconds or so to do this particular strip right here. And I'm going to draw it with a shape. I'm going to use this shape. So this one strip from here to here took me about 19 seconds. So I'll highlight that strip here in yellow for us so you can see it. So see if you can do a little bit of calculating here. Typically, I'll give my students this. We will have done some simple shapes, but when we get into composite figures, I really like, I don't want, to tell students what composite shapes are all about. I want to tell them after we actually use them. So we'll get some students actually using composite figures and finding the area without really knowing what it's called or what they're supposed to do here. They use a little bit of intuition in order to make that happen. So see if you can give it a shot. You see the width of the lawnmower here. I guess I should probably be a good person and do it a little more to scale, really, right? My lawnmower would be about that thick. However, it is 1.5 feet. So we'll give you guys a minute or two, or a couple minutes anyway, to try working that out. See how long you think that would take. Now, my students, I would usually have them estimate first, throw out some guesses, some highs and some lows, and then picking on their best guess, and then trying to calculate to get as close as possible. So give it a shot.